Good morning.
Good morning.
Good morning.
Good morning.
Welcome. Welcome to Friday. Okay, so today I want to go over metric prefixes as I continue to let people in. So here we are. Friday metric prefixes, and then here's a practice worksheet that has the same information we're going to work with in the jam. So if you feel like you'd like to have that handy, go ahead and maybe make a copy or pull that up right now. I seriously, okay. Alrighty, so we're going to talk about measuring things and then how we take a base unit and we convert it to a different size that everybody understands. And we really do that for convenience. So I'm going to start with the base units. In chemistry, we're going to make measurements of physical quantities. And a physical quantity so quantity is just an amount, and physical means is something that we can measure. We can put a number to. A physical quantity has both a number written to the correct degree of precision, which means the right number of sig figs, and units. And what kind of physical quantities are we going to measure? We will measure length. And our base unit will be the meter. And meter is abbreviated with a lowercase m. We will measure volume in units of liter, which is abbreviated with a capital L, or sometimes sort of a lowercase cursive L. I've seen both. Both are okay. Oh, mass, duh. Okay. In science, we're going to use thermometers that are in degrees Celsius. Oops. And time is in seconds. And mass is in grams. Now, how long is a meter? Like, can you, with your hands, decide how long a meter is approximately?
I always just think of it as a little more than 3 feet.
Yep. So a little more than a yard. If you can imagine a yardstick and then you just add 3 inches, that's about a meter. Good. So we measure things in meter, but sometimes that's really not the most convenient unit. Like if I was to measure the distance between Sierra College and the Exploratorium, which is a science museum in San Francisco, it would be 197,000 meters. And so there are times in science and in life when we just don't want all those zeros, and there's ways to handle it. We could write it in scientific notation. But sometimes instead of using scientific notation or exponential notation, which are similar but not exactly the same, sometimes we just use prefixes. So if I changed my meters to kilometers, kilo means 1,000. That would be like saying this: 197 kilometers. So it makes sense to measure the length of something that's very large with a unit that's larger than meters. And so we add the kilo prefix to add the times 10 to the 3 or times 1,000 multiplier. So prefixes like exponential multipliers just save us a lot of zeros. And when we're working with numbers that are really large or really small, it's great to get rid of those zeros. So that's one example. If I was measuring the length of my Apple Pencil in meters, it would be which is fine. There's not too many zeros there. But typically we like working with numbers that are like between 1 and 100. Like we're just comfortable with whole numbers, small whole numbers. And so if I was to measure this instead with centimeters, I would come up with this number. Let me just double check that. Yeah. So what the centi prefix does, I could change this number into scientific notation. So 1.675 times 10 to the negative 1 meters. Or I could just do it in exponential notation, 16.75 10 to the negative 2 meters. So scientific notation differs from exponential notation in that in scientific notation, to the left of the decimal, we have one digit that is not zero, between 1 and 9. But why don't I just take this 10 to the negative 2 meters and call that centimeters? So we use metric prefixes to change the size of the base unit, and they can be used for any of these base units. Typically, they're going to be used for things like length, volume, and mass. But temperature and time can also be adjusted with metric prefixes. So there's some that we just have to become familiar with. And if you have a paper copy of the book, this is on page 17 of Trove, 5th edition. And this is in section 1.6. So when we add those prefixes, the prefixes are one letter, and it matters if you make it capital or lowercase. D, for example, means deca, capital D, and lowercase d means deci. So capital or not capital does matter. If you're a person that writes in all caps, you're going to have to adjust that for this class. And then we always put the prefix before the base unit. So if I had milliliters, this L is the unit, liters, which measures volumes. And this M is the prefix, which changes the size of that volume, that base unit, by some measure of 10. Questions so far? No questions. Okay. So here are the prefixes that we will commonly use. In your book, there are more. Tro gets wild. He gets up to exa, which means 10 to the 18. I don't know any reason, unless you're taking astronomy, that you would need a metric prefix that large. And down to atto, which is 10 to the negative 18. So in our class, I'm going to limit my questions to these. These are the prefixes that you'll need to know. These prefixes are contained on the Jamboard that you're going to look at in a minute. And they're also, I believe, on the handout that you're going to get. I do want to add that for the sake of what we're doing, there are a couple extra ones. So what we're doing today, you might see nano. I don't know why that's so large, which is just a lowercase n. And nano is 10 to the negative 9. And there's a pico, which is 10 to the negative 12. So it's possible that you're going to run into those today. No worries. Right now, I want to talk about how do we equate the prefix with the order of magnitude. So I'm focusing on how we're going to connect this idea to that letter. Okay, so I'm going to focus on something that's common to us, which is centi. Okay, so C stands for centi. And centi means 100th, which could be written this way, or it could be written this way. So it doesn't matter which way you look at it. I'm going to kind of focus on the exponential. And because this number is less than 1, this exponent is negative. So how many cents in a dollar? There are 100 of these small things in the larger group we call a dollar. So how many centimeters would be in a meter is sort of an analogous idea. I could say it takes 100 of these 100th meters to add up to 1 meter. That's one way that we could apply the prefix and give it meaning and an equality. Why are we going to need to do that? Because next week we're going to use these equalities to answer problems using something called unit analysis, which is very powerful, not just in our class, but in other science classes too. So I can correctly interpret the relationship between centimeters and meters by putting a 1 in front of the base unit and then saying how many of these smaller things. But the other way that I can do it is just interpret what centi means. And so I'm going to do that this time. I'm going to say 1 centi of a meter is 1/100th of a meter. That is also a correct way to interpret that. The way that would be wrong, and sometimes students move toward this at the beginning, but you'll learn quickly, so hopefully you're listening right now. If I had centimeter and meter, and I was trying to come up with an equality, a relationship that we're going to use in the future, it would be wrong to put the meaning of the prefix next to the prefix. When I do that, I'm saying 100th, that's this part here, of 100th meter, as this part here, equals 1 meter. And that really doesn't make any sense. 100th meter equals a meter? No. Okay, are there any questions? Okay, so here's the Jamboard we're going to work with. And I've got these prefixes, and I've given them 2 columns. So here, and here are the same. Why are they the same? They're the same because it is possible to interpret this thing 2 ways. One is to use how many of these small things equal the whole, and the other one would be to use centi means 10 to the negative 2. So there's 2 correct ways to answer most of these questions. There is one that only has 1 correct way, and that's here with cc and milliliter. So I'm going to talk about that for just a second. Okay, so a cubic centimeter cubic is 3-dimensional, so length times width times height would be something like this.
We can't see you right.
Oh, thank you. Appreciate it. Would be something like this. So imagine that I've made a cube here, and this length is 1 centimeter, and this length is 1 centimeter. And the height is also 1 centimeter. If I wanted to know what the volume of that was, I would take the length times the width times the height. And I would get 1.0, 2 sig figs times 2 sig figs times 2 sig figs. My answer should have 2 sig figs. And centimeters cubed, because centimeters times centimeters times centimeters is cubic centimeters, just like x times x times x would be x cubed. And then if I was to fill that with water or anything, any liquid. So I'm going to fill this all the way up. What volume would be occupied? 1.0 milliliters. So 1 milliliter, and it doesn't, I'm showing it with 2 sig figs, but it does not matter. 1,000th of a liter is equal to 1 cubic centimeter, which is sometimes written as a cc. This is a relationship that you're just going to need to know.
I have a question.
Sure.
Why do we have the two different between milliliter and cc?
So for our class, if we were measuring things in a graduated cylinder, if we were measuring liquids, we would refer to the volumes in milliliters, which is a fluid idea. If we were measuring a solid, we would think of length times width times height, even if it was irregular. And so that would be cubic centimeters. And then the cc's, that's just a medical setting thing.
Okay.
You know, how
That's
many
fine.
milliliters of medicine? 2 cc's. I don't know why.
Okay.
Thank you for your question. Other questions? Okay. So what we're going to do here is you and your friends are going to figure out what goes here and what goes there. So 10 to the 9 nanometers is a meter, or a nanometer is 10 to the negative 9 meters. If our exponent is positive, that's a large number. If our exponent is negative, that's a number less than 1. And then I've also got, oops, here, the conversions that I think that you're going to need to know. Let me make this smaller. But I didn't include nano and pico, and so you're probably going to want to add those. Nano is 10 to the negative 9, and pico is 10 to the negative 12. You won't need nano and pico for Chem 1A, but you will need them for Chem 1B. Because we're doing things at home, you're welcome to have a prefix sheet next to you as you're taking an exam. If you were taking an exam and you thought it'd be easier to Google those numbers, what those meanings are, I would say that's cheating. When we take quizzes or exams, we're not Googling anything. But if you Googled ahead of time and made yourself a bunch of notes and you worked from those notes, that would be totally fine. And if that doesn't make sense why those are different in my mind, feel free to Zoom me or email and we'll have a chat about that. Okay, so at this time, I'm going to break you into your groups. And then, let's see, stop share. I'm going to break you into your groups and give you a Jamboard. And if you end up in group 4 or 5, sorry, you're going to have to wait a minute because it takes me a while to get to each group. I'll see you in a little bit.